Hello, my name is Doug Darfus, and today we're going to talk about solving literal equations, simple literal equations, one-step examples. This is taking a value that's known and using it in an equation to find out what's not known. Now, this is a very basic skill that many scientists and mathematicians must have in order to do their work. By the end of the tutorial, you should be able to solve basic equations for one variable. To solve an equation for one variable, we'll be using inverse operations. As long as we do the same thing to both sides of an equation, it will stay equal and balanced. For an example, if I have a balance and there's 3 balls on each side, then if I were to take away 1 ball on one side, I would have to take away a ball on the other side to keep the balance balanced. This is the same thing with equations. For our first example, the United States wants to send someone to Mars. At certain times of the year, the shortest distance between Mars and Earth is 36 million miles. We want to know how fast does the spaceship have to travel to get to Mars in 1 year. We start with an equation, distance equals rate times time, or d equals rt. We know that the distance is 36 million miles. We also know that the time that we want is 1 year. Now, in order to use miles per hour, I've already changed 1 year to 8,760 hours. What we need to know is r. How fast do we have to travel? So to do this, we start again with d equals rt. And we notice that it's rate times time. We want to do the inverse operation of multiplication, and the inverse would be division. We're going to divide both sides by time. On the right side, the times cancel out, and so we get distance over time is equal to the rate. This is the equation that we will use to solve our problem. So we start with rate equals distance over time. We're going to substitute in 36 million miles for distance and 8,760 for hours. We do the division and we realize that it's about 4,110 miles per hour. The space shuttle goes faster than this once it gets past the Earth's gravity, so we should be able to do it. Another example, let's say you're designing a new tilt-a-whirl, and we know the circumference is 135 feet. And you need to know the radius to design the beams to hold each car. Well, the equation that we need is circumference equals 2 times pi times the radius. We know the circumference, it's 135 feet. We know pi is about 3.14, and what we're looking for is the radius. So again, we'll start with the equation we know, circumference equals 2 times pi times the radius. And we're going to solve for the radius. To do that, the inverse operation of multiplication is division. So we'll divide both sides by 2 pi. On the right, the 2's will cancel out, the pi's will cancel out, and so we'll get circumference divided by 2 pi is equal to the radius. We can then use this equation to solve our problem. Radius is circumference over 2 pi. We substitute 135 feet in for circumference, 3.14 in for the pi, and we get that the radius of the tilt-a-whirl is about 21.5 feet. Our next example, we're talking about a catapult. We're going to shoot a steel ball off of a building. We want the ball to be in the air for 5 seconds. The initial velocity of the ball is going to be 30 feet per second. And we need to know what height we need to launch the ball from so that it will stay in the air for 5 seconds. The things that we know are h. H is the height of the ball at any given time, and the time we want is when it hits the ground, so the height is 0. We know t, the time, is 5 seconds. We know v, the velocity, is 30 feet per second, and we're trying to find s, the initial height. So we're going to start with the equation h equals negative 16t squared plus vt plus s, and we're going to solve it for s, what we need to know. We can see that there's a negative 16t squared, and so the inverse operation would be adding 16t squared. That leaves us h plus 16t squared equals vt plus s. And again, we're trying to find out what s is, and we can see that vt is added to s, so the inverse of adding would be subtracting. So we're going to subtract vt, and we end up with h plus 16t squared minus vt is equal to s. And we can use this equation to figure out our problem. So we substitute the values in, 0 for h, 5 for t, 30 for v, and we do the mathematics, and we come out with the initial height has to be 250 feet. So in summary, to solve an equation, it's good to know what information you already have and what information you need. The information you need is the variable that you want to solve for. To solve for the variable, we undo the equation by using inverse operations.